Welcome back. Today we're going to talk about writing expressions. So the first example is I want you to translate the verbal phrase, the quotient of 5 and the quantity 3 more than a number n. I want us to translate that into a mathematical expression. Okay? So let's pick apart this phrase. The quotient of, all right, this phrase right here indicates that what we're looking for is a fraction of something, okay? So that's the information that this gave us, is that the next thing that we're going to see, the next thing that's mentioned is going to be the numerator, okay? The quotient of what? Okay, so we have a quotient. All right, now I'm going to be in the next part of the phrase looking for a numerator and a denominator. So the quotient of 5, stop. This word and is going to separate the numerator from the denominator. So the quotient of 5 and the quantity 3 more than a number n. All right, so this right here is going to be the denominator. Now, this is oftentimes how a sum is written. It's written as like if I say that 7 is 2 more than 5, then I take 5 and I add 2 to it. Okay, so this is going to be the same here, where it's not going to really matter so much with addition, but with subtraction it will. So I'll show you what I'm talking about in just a second. The quantity 3 more than a number n. So what this means is you're starting with n, and you're adding 3 to that, because this is n plus 3 or 3 more than a number n. Okay. So let's just look back at this entire phrase. The quotient of, okay, so it's the quotient of 5, and in the denominator we have 3 more than a number n. All right, so this is the expression that was indicated in the verbal phrase. Now, the quantity 3 more than, sometimes you'll see a number decrease by 5, for instance. So here, this is pretty straightforward. You have n minus 5. But sometimes you'll see the phrase 5 less than a number. I'm just going to put this little symbol here for number. 5 less than a number n. Okay, now this is the same thing as this algebraic expression I just wrote, but it doesn't look the same. It looks like the phrase has been switched around. So oftentimes what students will do is they'll say 5 less than, because they want to translate it immediately so that they don't forget it. So they'll say they encounter 5 first, so they'll write 5 down, and then they'll write minus n. But think about what this is. This is n, this is 5 decreased by a number n, or n less than 5. Or n of a number 5 less by a number n. Or that's a little tricky, but it's switched around from what it should be. All right, let's write it the correct way. It should be 5 less than, well, less than what? Well, it's less than the number n. So we start with n and we decrease it by 5. Okay, so it didn't matter so much that this phrase right here was addition, because it would have been the same if it were 3 plus n. But technically, this expression is the way you should write it, because 3 more than a number n means you start with n and then you add 3 to it. But again, it's not going to matter so much because these two are equivalent expressions, but it absolutely will matter when it's subtraction, because 5 minus n is not the same thing as n minus 5. So make a note of that in your notes. That's a really important idea, that when you see less than, it's often a reverse statement. Okay, we want to write an expression for the phrase, the price of lunch plus a 15% tip. Okay, so the variable wasn't indicated for us. So let's say that this cursive L means lunch. Lunch price, we'll say. Okay, so the price of lunch, so we take L and we want to add it to 15% of, plus a 15% tip for lunch. So it'd be 15% of the lunch price. That's the word of, and this is our cursive L. So of means multiplication, so you're taking 15%, let's write it as a decimal, 0.15 times the lunch price. Okay, so we have the lunch price plus 15% of the lunch price. And actually, we could simplify this a little bit because they both have L raised to the first power. So if we put this as a coefficient, it would be 1.15 times this lunch price. So that gets us the lunch price itself plus 15% of itself. Okay? And finally, let's say, this is our last example. Last month, Lizzie volunteered 20 hours at her town library. Okay, I'm going to write that down, or I'm going to underline it. In the weeks to come, she plans to volunteer 5 hours per week at the library. Write an algebraic expression that represents how many hours she will have worked W weeks from now. Okay. Well, if she's doing 5 hours per week, then that's going to be 5 times W. So 5 times the amount of weeks she has left will be her the hours she volunteers from the hours last month. Now to this, where we want to add the hours that she did last month, so that we have 5 times the amount of weeks that she has left plus the 20 hours that she initially volunteered. All right? And so that is our expression for this situation. And that's the end of the lesson for today. Thanks.